Alright, so we're about to get into the math portion of this class, and what you really need to know is that anything that you learn in this unit for math will never ever go away. A lot of things in this class never really ever go away, and it's really important that you get it now instead of struggling later. Alright, so we're going to talk about accuracy and precision and a little bit about significant figures, and then tomorrow, or next podcast, we will get more into significant figures. Alright, so let's talk about accuracy versus precision. A lot of people use these two words interchangeably, but they're not the same thing. Accuracy is how close a measurement is to the real value. So how close it is to being correct. If I measure the density of something and I said it's 2 grams per milliliter and it's actually 1 gram per milliliter, I'm not very accurate. I haven't gotten very close to the 1. So accurate is just basically how correct you are. Precision is how close a series of measurements are to each other. So if I take the same measurement 5 times, or if a group of students take the same measurement 5 times, how close are the measurements to each other? So basically, accurate is correct and precise is consistent. And precision also has to do with significant figures, which we're going to talk about. Alright, so let's say that I am a knife thrower and I am trying to show off my great knife skills. So basically, I am trying to not hit this person, so I don't want to kill him, and I want to show that I can be very consistent with my knife throwing skills. So right here, this is accurate and precise because I did not kill the person, so I was accurate, and all of my knives went into around the same spot, so that's precise. So this is when I'm accurate and precise. So I can also have one or the other too. So right here, when I was throwing the knives at the person, well, the person's dead, so I'm not accurate, and I'm also not precise because all of my knives are all over the place. So this is when I'm not accurate nor precise. Alright, so right here, I've killed the person, so I'm not accurate, but I was precise because I got all of the knives in the same spot right here. So this is precise but not accurate. And you can also be accurate but not precise. Alright, so if I want to measure how correct I am, I can use percentage of error. So when you write this formula down, please make sure you write down what experimental and literature means. So basically what I'm going to do is I'm going to compare my value, the value that I either calculated or measured, to the value that it should be. So experimental is your value. So whenever you go in the lab and you get something that is your value, that's the experimental value. Literature, or it can also be something that you've calculated. And the literature value is the real value, what you should have gotten. So in order to get percentage of error, I'm going to take my experimental, so that's the value that I got in the lab or I calculated. And I'm going to subtract the value that I should have gotten. And I'm going to take the absolute value of that and then divide it by what I should have gotten times 100 because it is a percentage. Alright, so let's do a problem. So a student determines the density of a substance to be 1.40 grams per milliliter. Find the percent error if the accepted value of the density is 1.36 grams per milliliter. So I'm just going to basically plug it into the equation. So you should be copying this down and make sure you show all the work. So make sure you actually copy it down. So 1.4 is the value that the student got. So that is the experimental value. 1.36 is what the student should have gotten. So I'm going to subtract 1.36. I'm going to take the absolute value of that. It's not really necessary here, but I'm going to do it anyway. and then I'm going to divide it by 1.36 times 100. So make sure that you are following the steps correctly. So you want to subtract first. So follow your order of operations. All right, so I'm going to subtract first. I'm going to get 0.04, and that's going to be positive. 1.36, so I'm going to divide it by 1.36 and multiply it by 100. Follow the order of operations. So divide first and then multiply it by 100, and then I should get about 2.9% of error. So 2.9 for this class, if you can get below 5%, I usually consider that a pretty good percentage of error. And also, you should never get a negative value. So no negative values here, because you're taking the absolute value at the very beginning. Alright, so a lot of students, when they come into my class, they do not know how to take a proper measurement. So really that depends on the significant figures, and that indicates how precise your measurement is. And we're going to really get into significant figures in the next podcast. Alright, so when you have a measurement, how precise you are really depends on the measurement, or the measuring device. So right here we're going to have a ruler, and I want to measure the length of this paper clip. Okay, so right here I have the paper clip. It goes from 0 to kind of over here. My line's not very straight here. Alright, so I know that it's at least 2 centimeters, and then I count the dashes. This is 1/10 of a centimeter. So this is 1, 2, 3. So it's definitely at least 2.3 centimeters. So, but it's a little bit beyond 2.3. So I'm going to say that it's 2.35. I estimate that last number. This number right here, I estimated that. Okay, so whenever you're taking a measurement, there should be at least one estimated value, unless you're using a digital scale. That's a little bit different. But let me show you something else. So I'm going to take the measurement of this paper clip again, but I'm going to use a different type of ruler. So I'm going to draw my ruler right here. Okay, but this one only has big dashes. So right here, this is 1 centimeter, 2 centimeters, 3, 4, but there's no little dashes in between. Okay, so I'm going to measure the paper clip again using this ruler right here instead. So I'm going to go ahead and put the paper clip up to it. So I'm going to see that it's at least 2 centimeters here, but it's beyond 2 centimeters, so I'm going to say that it's about 2.3. Okay, here is the difference. I estimated this number right here. So this value is actually somewhere in between 2 and 3. That's a large gap. This number, I estimated a 0.05. So really, the measurement is somewhere between 2.3 and 2.4. This one is a much smaller gap. So if I have a gap of 2 to 3, if I go and I take this measurement again, I may not get 2.3 again. I'm probably going to get 2.4. Somebody else will get 2.4, 2.5, 2.6, 2.2, somewhere like that. Those measurements are not very close to each other, so they're not very precise. But right here, I will get values in between 2.3 and 2.4. So that means that whenever I take a measurement or somebody else takes a measurement, they're going to get somewhere in between these numbers, and they're going to be more closer to my measurement, so it's more precise. You really need to make sure that you are estimating that last digit, okay? So the more dashes or the more numbers you can get from a measuring device, the more precise it is, because it will give you a consistent measurement. Alright, so we're going to talk about significant figures more in the next podcast, and I will see you in class.